Hello calculus students and welcome back. Today our work is with assignment 15, section 4.3, and we'll be looking at how to find the derivative of the inverse trig functions. So let's do a little groundwork first. If we look at the graph of sine of x, we know that it is periodic. And we know that since it fails the horizontal line test, as this indicates, the inverse will not be a function. And so hopefully you remember from excuse me, from pre-calculus that we need to do a restriction on sine of x in order for its inverse to be a function. And we restrict it to the domain minus pi over 2 to pi over 2, and we get a graph which looks like this. That's a restriction of the graph of sine of x, and it's helpful to note that it's known as principal sine of x, and it's written with a capital S to distinguish it from regular sine of x. This function does pass the horizontal line test, so its inverse will be a function. And it's also important to note that principal sine attains all the possible values from -1 through 1. So now let's look at the inverse of this function. So what you see is simply the graph of principal sine of x. It's the restriction of sine to the values minus pi over 2 to pi over 2, and the range of this function goes from -1 to 1. So it makes sense that when we talk about the graph of the inverse of this function, that it will go from -1 to 1 on the x-axis, and from minus pi over 2 to pi over 2 on the y-axis. And since we have the point pi over 2, 1, over here we'll have the point 1 pi over 2. Similarly down here, and here, and here is what the graph of the inverse of principal sine is, and we write it with a capital A. It's a little different than the way the book writes it. The book usually uses a small a, but I think it's much more helpful to distinguish the fact that here is principal sine with a capital S, and here is the inverse of that with a capital A. And so if we examine this graph, what we notice is that right around here it looks like the slope could be 1, and right over here it looks like the slope will be undefined, and the same thing over here. So what we're looking for, then, when we talk about the derivative of R Cosine of x, slope of the tangent line, is some function which is only defined from -1 to 1, which has the value 1 when x is 0, and which is undefined when x is 1 and -1. So try to keep those facts in mind as we go ahead and actually create the derivative of R Cosine of x. So we begin by saying, okay, let's let y equal R Cosine of x. And so what we're really looking for is dy dx. So we use the relation of inverse functions. If y is equal to arc sine of x, that means that the sine of y is equal to x. If we differentiate implicitly, we get cos of y times dy dx. There's that chain rule, is equal to 1. And so therefore, we were looking for dy dx. Well, dy dx is equal to 1 over the cosine of y. Well, that seems okay, except the problem is that we like to write our expression for dy dx in terms of x. So here's how we do it. If we take a look at the relationship that sine of y is equal to x, we can draw a little right triangle which shows that. Here's angle y, and if the sine of y is x, then the opposite over the hypotenuse has got to give you x over 1. That forces this side to be 1 minus x squared. And so therefore, dy dx is equal to 1 over the cosine of y. And if we look at our picture up there, that's simply going to be 1 minus x squared. And so there is the derivative of arc sine of x. Now let's remember, if x is 0, the derivative is 1. Remember, that's what we wanted to have happen. This function is only defined when x is between minus 1 and 1. And when x is 1 or minus 1, the derivative is undefined. And so it satisfies all those conditions that we expected it to satisfy when we examined the graph of arc sine of x. Now, in a very similar manner to the way we derived the derivative of arc sine of x, we can derive the derivatives of all the remaining ones. What's interesting to note is the pattern here. Here's the derivative of arc cosine. And notice that it's the same as the derivative of arc sine, only negative. The derivative of arc tan is this. The derivative of arc cotan is minus that. The derivative of arc sec is a little different. It's 1 over the absolute value of x times the square root of x squared minus 1. And arc cosecant is minus 1 over the same thing. So that's our table for all of the derivatives of the inverse trig functions. And notice that really they come in pairs. Here's one pair, second pair, third pair. So pretty easy to remember. You really only need to know 3 of them to remember them all. Alright, so let's look at a few examples and then we're done. Alright, so these are 2 examples that should help you see how to find these derivatives. So for the first one, we're looking for the derivative of arc sine of 3x minus 5. So again, this is an application of the chain rule, and we'll see that this is equal to, the derivative of arc sine of something is 1 over the square root of 1 minus that thing squared. And the chain rule tells us we got to take the derivative of that thing. Similarly, the derivative of arc tan of something is 1 over 1 plus that thing squared times the derivative of the innermost function. And that's how you do those, so not very difficult. So at this point, just to kind of keep track of where we are, we know how to take the derivative of any polynomial, any rational function, thanks to the quotient rule, all of the trig functions, all of the inverse trig functions. So all that's left is to learn how to take the derivative of exponential and logarithmic functions, and that'll be the subject of the next lecture. See you then.